right, and welcome back. This is Raul. This time around, we're going to be talking about the filtering possibilities for the standard VCO. And for this demonstration, we're going to be using two filters. The one here on the left is going to be the A101-2 low pass gate. We're going to be using it in low pass mode here on the left. That's that switch right there. It does have two other modes, but we're not actually going to go into those. For our purposes, I want to keep it kind of focused on just basic filtering, standard VCO. So that's what we're going to talk about. Low pass filtering using the low pass gate. Second one over here is the A120 standard low pass filter. Now both of these are low pass filters, but one of them is a 12 decibel low pass filter, and that's this one right here. And then the other is a 24 decibel low pass filter. I'm not going to get too much into the technicalities of what that means, but when we get into the demonstration portion, you will definitely hear what the difference is between the two. So before we jump into the demo, I want to just talk a little bit about some of the basic ports and dials that are on each one of the filters. So on our first filter, the A101-2, we have some inputs here for CV, control voltages. We have a CV1 that's going to allow us to modulate the frequency setting of the low-pass filter. So this right here is going to be telling the filter what frequency we want to filter the incoming signal at. So all the way clockwise or counterclockwise, the filter is going to be closed, so there'll be no signal passing through the filter. And all the way clockwise, right there, all signal will be passing through. And then somewhere in the middle here, you can filter out certain frequencies of whatever waveform you're feeding it. This will become a little more clear once we get into the demo, and it'll start to make a little more sense. So, but that's the first row of inputs and dials. The next row down, CV2. CV2 is going to be identical to CV1, except for it's got a CV2 level that you can control. So you can feed this modulation from a modulation source, such as your A145 over here. You could feed it a inverse saw, sine into CV2, and then you can adjust the level of modulation going into the filter. And what that's going to do for you is it's going to change the frequency, just like CV1 did, of the filter. Okay, moving right along, audio in. This is going to allow you to input your audio. So we're going to be patching the audio output of our oscillator into the input. And then here you have a basic level adjustment, so how much of the input signal you're going to feed into the filter. Immediately below that, we have our audio out, and then we have a resonance dial here that's going to allow us to adjust how much resonance happens on the filter. So all filters have something called a cutoff. That means where the filter is actively filtering. So like if you were to imagine that this was the frequency for the filter, like let's say everything counterclockwise to here would be filtered out, and then everything clockwise is going to be feeding through the filter. So wherever our resonance setting is, the more resonance you have, the more it kind of attenuates or increases the frequencies right at the cutoff point. Technically that sounds very interesting, but once we hear it, it's going to make much more of an impression, and you'll know, oh, okay, that's what it sounds like when you have a lot of resonance or you have very little resonance. According to what I read in the manual, it uses the term, you can boost the resonance all the way into self-oscillation, which basically starts to sort of make another pseudo-oscillator sound. So then you have your original signal as well as the filter oscillating at whatever frequency you have it set at up here. And we'll hear what that sounds like as well. These two inputs down here relate more specifically to this type of module. They allow you to send a signal to this device, and sort of instead of having to manually switch modes with a switch. You can use signals to send to here and have it switch modes as well. I'm not going to be doing a demonstration of that. I'll save that for a different time, but just wanted to let you know I'm not ignoring these two inputs here. Okay, so that takes care of the low pass gate, at least just a basic explanation. Now we're going to move on to the A120 low pass filter. And the first row is essentially the same. We have a CV1 that's going to allow us to patch a signal into the frequency and then modulate the frequency setting that we have on that filter. And then on CV2, nearly identical to CV2 over here, you can input a modulation signal, and then you can adjust how much of that modulation signal is going to be going to the frequency of the filter. In a lot of our other demos, you may have remembered how if you feed it two signals, like let's say CV1, CV2, the two inputs are summed and then sent to whatever those two CVs relate to. So in this case of the A101, you would be summing the two modulation signals here, and then they would go to the frequency setting of the filter. The same is going to be true here. So you're going to have CV1 and CV2 summed if you have inputs at both of these, and then they're going to be sent to the frequency setting that you have on the low pass filter. Now, one little curveball with this filter here is we have yet another CV here. So before, on the other modules we've been looking at, we've had primarily two CV inputs. One pretty much straightforward modulating, and the other where you could adjust how much of that modulation is actually going to affect the sound. But here you actually have three. So when you patch in all three of these, it's going to do just what you think. It's going to sum all three of these, and then it's going to send that signal into the frequency of the filter. So there you go. Even more sonic capabilities there. Down here, audio in. Just like this one over here, we have audio input. This is also an audio input, so that's where we're going to put our signal in. And then you can, of course, adjust the level. And then right below that, we have an audio out. That's what we're going to patch out from to go to our mixer over here. And then, of course, we have another resonance setting that we can go all the way clockwise to the full resonance of the filter, or we can go all the way down to the counterclockwise position, at which point we have no resonance. And as I said, once we get into the demonstration, we'll be able to hear what exactly that's going to sound like. The only other thing I'll mention about this filter is that, remember when we mentioned that this one is a 12 decibel filter? Just want to reinforce, this one is actually 24 decibel filter, so we're going to hear what the difference in that 12 decibel difference between the two filters is going to sound like. The other unit that's going to come into play here is the multiples. That's the A180 multiples is going to come into play. And basically what this module does is it splits your signal. So whatever you feed it, I'll demo that really quick because it's going to come into play a little bit later. If I feed it a sine wave here, patch it right in, now this signal has been duplicated at this output, and this output. So, and this actually has two halves. So whatever you patch to the top one gets duplicated 3 times, and then you have room to patch yet another signal here, and it gets duplicated 3 more times. So just so you can see what that sounds like, I'm patching a sine wave into there. So technically I can patch out from there into my input over here, and I should hear a sine wave, and I do. And then I'm going to patch into this one, and then I'm going to patch into input 2, turn it down a little bit because that might be a little loud. So now I have 2 sine waves. Basically it's twice as loud, and actually it's a little too loud. It's kind of blowing out my speakers a little. So I'll turn that down. And so that's the idea of the multiple. Where this is going to come into play later, I'm going to unpatch this, is I'm going to try and patch the same signal into two different filters so we can kind of hear what the difference is between the two and how that's going to affect our sound.